Hi kids, time for second day of graphing sine and cosine. Really all we're going to do is add one more component to our graphing because so far we have practiced changing our amplitude and or dilation factor, right? We have practiced changing our period and we have practiced changing our sinusoidal axis. What haven't we done so far? Phase shift, right? So let's graph this without a calculator, starting with our roadmap of success, where we start with our sinusoidal axis. There's no vertical transformation. My dilation factor is 1/2. My period is 2 pi over b, which is 2. Therefore, my quarters are 2 divided by 4, or 1/2. But this time, my phase shift is not -2, is 2. And my phase shift is where I'm going to start my cycle. Here's the top of my road. Here's the bottom of my road, and I am going to start my trip at 2. How long am I supposed to go? Take your start and add your period. What is the length you're supposed to travel? I'm supposed to travel 2 units, starting at 2, for a total where I end then at 4. I'm just going to stick my end there. And then my quarters, so I'm going to go about 2.5, 3, 3.5, and 4. Kind of terrible. Since I'm graphing sine with a positive dilation factor, I'm going to start on the sinusoidal axis, go up to the max, back down to the sinusoidal axis, fall to the min, and finish on the sinusoidal axis. Label, start comma sinusoidal axis, 5/2 maximum, 3 sinusoidal axis, 7/2 minimum, 4 comma sinusoidal axis. Okay, so not so bad. Just same graph, shifted 2 units to the right. Let's practice one more of those. Careful. My sinusoidal axis is at -2. My amplitude is 3. So the distance from the sinusoidal axis to the maxes and mins. My period is 2 pi over b, which is of course 2 pi times 4 over pi, which is 8. So I'm going to go a distance of 8, but my phase shift is not pi. My phase shift is not -5 pi. You have to factor pi over 4 out of this term and get just a t, but you have to factor pi over 4 out of pi. Which of course is pi times 4 over pi, which is 4. So in reality, you have t plus 4 in there. So my phase shift is not 4. What is it? -4. That's where I'm going to start. Add your period to get where you stop. And of course, my quarters are my period divided into fourths, representing the 4 quadrants, and that's a 2. So I'm going to start over here at -4. I'm going to end at +4, and my quarters are 2. So -4 plus 2, -2 plus 2, 0 plus 2, and 2 plus 2. Since I'm drawing a positive cosine graph, I'm going to start at a maximum. So start at -4 at a maximum. Whoa, I didn't mean that to be white. Hit the sinusoidal axis at the first quarter, the minimum at the next quarter, back to the sinusoidal axis, finish at a maximum. Label. -4 comma maximum, -2 comma sinusoidal axis, -0 comma minimum, 2 comma sinusoidal axis, 4 comma maximum. All right. Phase shift, horizontal translation. Complete though with one cycle and all the start and your 4 quadrants labeled. All right, last thing. Look at these 2 statements and the 2 graphs of sine and cosine. Can you intuit why they're talking about a phase shift, right? Is sine x the exact same thing as sine plus or minus a phase shift of 2 pi, right? If you copy and paste one cycle and move your start 2 pi units to the right or 2 pi units to the left, you're going to get the same graph, right? It's all about going around and around that circle. Starting at 0 comma maximum, if you shift 2 pi units to the right, you're still going to be a maximum. You're going to draw the same graph. If you shift 2 pi units to the left, same graph. But what about these statements? Right? What does this say? Sine x is the same as as if you would graph the sine x. I would get this graph if I had instead asked you to graph the cosine starting pi over 2 units to the right. So take this sine graph. If I'd asked you to graph cosine of x minus pi, you would start at a maximum at pi over 2, wouldn't you? And you would draw this graph. But isn't that the same as sine x? So sine x can be written as a cosine graph as long as you move pi over 2 units to the right. Cosine can be written as a sine graph as long as you move, right? You can just change cosine to sine as long as you phase shift, right? So here's cosine. If I asked you to graph sine of x plus pi over 2, you would start on the sinusoidal axis at negative pi over 2, and this is the graph you would draw. So cosine can be rewritten as a sine graph as long as you add pi over 2. So here's how 2 examples of that. What if I'm giving you 2 cosine graphs, but I want you to rewrite them as sine graphs. So I want to legally change, I want to keep y the same, I want to legally change cosine to sine. This dilation factor is 1, keep the same dilation factor. I had x minus pi. What's the price I have to pay for changing cosine to sine? What's the price I have to pay? Add pi over 2. If you graph these 2 equations together, you will get the exact same graph. Can you do the same thing for B? I want to legally change this cosine graph to a sine graph. Keep the dilation factor the same. What's the price I have to pay for changing cosine to sine? And of course, there's lots of other, right? With the periodicity of these graphs, there's lots of other things I can do. If you put both of these equations, one into y1 and one into y2, you will get the exact same graph. Cool beans. Trig is cool. All right, so we'll do some more practice with graphing and labeling. Without a calculator, we will also practice some things with a calculator, right? Trying to get used to when I have a calculator in my hands, right? What am I supposed to do with it? We'll also do some group activities or look at some Desmos activities and to practice manipulating these equations. And we will do that when I see you next live session.